Let us consider the next problem. What we are given here is there are two spheres. These two spheres are held in a channel. You are given the width of the channel. You are given the weight of each sphere, which is 100 newtons. The radius of each sphere is 250 mm. All the surfaces are considered to be smooth, right? And you are asked to find out the reactions at surface A, B, C and D. Okay, so this is the problem. Remember, when they say the surface is smooth, that means there is no friction, and when there is no friction, the only force at the surface where the sphere or other body is touching is normal to the surface. When the surface is not mentioned as smooth, then there could be friction and we have to consider that force, but at the moment we don't have to get into that. Essentially, we remember that the normal force to the surface at the point of contact is going to be perpendicular to the surface. That is what we want to get from this. Okay, so how do we proceed? We can first find out, draw the free body diagram. Essentially, it means that we will identify the forces and represent them on the body. Okay, so we can see here that these two bodies have got weight. So these forces, the weight is going to act downward, right? And these are the two forces acting downward. We can say these are the forces acting downward, and we call them, let's say 100 Newton here, 100 Newton, because they are having the same weight. Then there will be a reaction at A and at C. A and C surfaces are vertical, so the reaction is going to be perpendicular to it, right? So reaction is going to be perpendicular, and remember, these surfaces are tangent to these circles. Okay, there is a sphere, but the projection here is circle, so they are tangential. It means perpendicular to that, the normal force has to pass through this radius. Similarly, the normal force has to pass through this radius. So I will show that the force is passing here, and I will show the force in this direction. So this is RA. So this A perpendicular, I am just extending it, passing through the center. Similarly, C passing through the center. So this is RC. Okay, fine. Then what else we have? We have a force here, right? A normal force here, and we have another contact here. Okay, so what is the contact here? Please note that the contact here is between two spheres, right? And so again, this is the contact point. The normal has to be, so imagine a tangent through this, right? This is a point of the line of contact, and through that there is going to be perpendicular force. That means this sphere is exerting force on this, the lower sphere, and the lower sphere is giving reaction, right? So the reaction will pass through the center. So this is the reaction passing through the, and this, since this point of contact is D, I will call this as RD. Similarly, this sphere is acting on the lower sphere. That means there is a force on this. This force is the reaction of this sphere on upper sphere, which I have extended here. This sphere will be subjected to some force by this at point D. So that means again that is also going to pass through the center, because this is tangential, and if you draw it, it's going to pass through the center, and this is your RD. Okay, this is RD. So these spheres are subjected to three forces. One is weight, another is the point of contact with the vertical surface. These are the forces. Then you have the reactions from the forces passing through this point of contact. So these are the three forces. Now that means now you can just remove it. We have in a way drawn of the free body diagram, right? But now what we want to do is we want to find out the angles of the forces. In this case, see, if you these two forces, this force and this force, are the only forces which are non-vertical or non-horizontal. That means they have some angle with the horizontal, and we want to find out that angle. That's all. Once you find out that angle, then we can resolve the forces. Of course, here we will consider, there is a small correction I will make. Wait a second. Yeah, sorry. So that's right. So basically we want to find out angles. But here we also have to show that force here, normal force, because this is resting here. I can show it here upward, but instead of showing it upward, I can show it here. And that is RB. This is RB. Okay. So you have forces now. So basically RB and RA and RC all are either and the weights are vertical or horizontal, except RD, the force RD, right, acting on two cylinders. Now we want to find out this angle. So how will you find out this angle, right? And that's the central point in this problem. So the way to find out this angle is as follows. So consider these 2 points. Consider these 2 points. Now you know that the distance between these 2 points, dotted line here, I am drawing a dotted line, that means this line is how much? The radius is 250 mm, right? So this is 250 and this is 250. So this is 500. So this is 500. So this is the line of action of RD, right? And you can see what is this distance. So you can also consider the width is 900, right? So the distance between center to center, this horizontal distance, right? This horizontal distance is 900 minus 250 minus 250. So 900 minus 500, so it is 400. This is 400. And you want to find out this angle, right? So please note that this is the triangle we are considering. This is the triangle we are considering, okay? And we want to find out this angle. Now finding out this angle is easy, right? So it is going to be 400 by 500 will be cos of theta. So theta is equal to cos inverse of 400 by 500, okay? And this angle will be 36.87 degrees. 36.87 degrees. Right? Once you find out that, now we can consider these all the forces acting on separately on these spheres. Write down sigma fx is equal to 0 and sigma fy is equal to 0. Why? Because the system is under equilibrium, and this is a system. If you consider these two spheres, the forces are concurrent forces, and they are passing. That means passing to the center, and coplanar concurrent forces, bodies under equilibrium. It means sigma fx is equal to 0, sigma fy is equal to 0. So for these two spheres, write down these equations. So let me write down these equations. Consider the lower sphere, and so we have found out this angle, right? This angle is 36.87. Similarly, this angle. So we can resolve the forces. So consider only this sphere. In this sphere, RD is the force. So let's say sigma fx is equal to 0, right? So we write equation. RD resolve horizontally. RD means RD is in downward direction. When you resolve horizontally, it is cos of 36.87. It will be towards left. So I'll write minus RD cos 36.87, right? Then we have this, so RA, please note, RA is in this direction. I should clear this. This is, so this is RA is in this direction. So plus RA is equal to 0, because for this sphere, the only forces that will have horizontal component, one is RA which is in horizontal direction, and the other is RD, which is resolved, right? This is 0. So this is equation number 1. Now vertical resolution, there is a force RB, right, which is upward. So sigma Fx Fy is equal to 0. So this will give us RB, right? Then this horizontal will have no bearing, minus 1000 downward, minus 1000, sorry, not 1000, 100, and this RD sine of 36.87 in downward. This is 36.87, downward it's going to be minus. So minus RD sine of 36.87. This is equal to 0. This is equation number 2, right? This is equation number 2. So you have two equations. Now let's go to upper sphere. Let's go to upper sphere. So in the upper sphere, you have RD, you have the weight, and you have RC. So RD resolve, this is 36.87. When you resolve it horizontally, it will, look at this arrowhead, it will be pointing away from the center. When you resolve it, it will be towards right. So we'll say positive. So it is resolve sigma Fx is equal to 0 for the upper sphere. So it is RD cos of 36.87, right? RC is towards left, so minus RC is equal to 0, right? Similarly, resolve it vertically, sigma Fy is equal to 0, RD sine of 36.87 and upward, so it is positive. RD sine of 36.87, right, is equal to 100. So this is third, this is fourth equation. So you have 4 equations and you will find out all the unknowns, right? You will find out all the unknowns if you solve this equation. You can directly get RD from here and then substitute it here, get RC and proceed that way.